Welcome to the second part of video lecture on projectile motion. So this part of the video lecture will learn about projectile motion on inclined plane. This is a typical arrangement what we see in the figure. So what we see here is this is a projectile, velocity of projection is u and angle of projection is theta, measured from horizontal, a typical projectile u and theta. But unlike previous cases, what's the difference here? The point from where we're projecting. In previous cases, the point of projection was on a horizontal ground. So motion of the projectile also will used to come to an end when the projectile used to hit the ground, which indirectly implied the y coordinate, final y coordinate of the projectile motion was again at y is equal to 0. So the time of flight as well as the range corresponded to a point which was on the same horizontal level. Thus where the difference comes in case of inclined plane. What we see here, the point of projection is on an inclined plane, which makes an angle alpha from the horizontal. So it's not a horizontal surface. So we fire a projectile from here, but its motion will be little different from motion of a projectile on a horizontal ground. Let's see what the difference would be. So we fire a projectile from the initial point on inclined plane. It takes the same path as before, but moment it hits the point P on the inclined plane, its motion comes to a stop. So compared to the projectile on horizontal ground, the time of flight will be shorter, and it will not, final y coordinate also will not be equal to 0, and the range also would be smaller. Because these are two important parameters, time of flight and range. So time of flight will be shorter if angle alpha is positive, and the range also will be smaller compared to the standard formula what we calculated for projectile on horizontal surface. So if we can calculate the point P, coordinates of point P where the projectile hits the inclined plane, rest of the quantities can be easily calculated. So first we'll focus on finding out what will be the coordinates of point P, x0 and y0. So let's understand the point P, x0, y0. What is special about this point P, x0, y0? As we see on the figure, the point P lies on the intersection of inclined plane and the trajectory of the projectile. So since it lies on the inclined plane, the y0 by x0 will be equal to tangent of alpha. Y0 by x0 will be equal to tangent alpha. In other words, we can say the y0 will be equal to x0 tan alpha. So this point y0 will be equal to x0 tan alpha. But since this point lies on the trajectory as well, the coordinates of this point must satisfy the trajectory equation. The coordinates of point P, x0, y0 must satisfy the trajectory equation of the projectile. Which projectile? Speed of projection u, angle theta. So if you substitute these values, let's put these values here in place of y, y0, which is also equal to x0 tan alpha, is equal to x tan theta. In place of x, we substitute x0, tan theta is same, minus g x0 square by 2 square cos square theta. What is theta here? Theta is the angle of projection and alpha is the angle of the inclined plane. If you look at this equation, to find range, first what we'll do, using this equation, first we'll find out the value of x0, x coordinate of point P. x0 can be easily calculated from this, one x0 gets cancelled, the equation comes to tan alpha is equal to tan theta minus g x0 by 2 u square cos square theta. This equation, there is only one unknown, which is x0. For a given value of alpha, theta, u, x0 can be calculated. And once we find the value of x0, using this right angle triangle, we can also find out distance OP, because OP into cos alpha is equal to x0, or OP is equal to x0 by cos alpha. Once we find x0, range also can be formed. So let's take example. Suppose the alpha is 30 degree. So angle the plane makes from the horizontal is 30 degree. Angle of projection is 60 degree. Of course, the theta has to be greater than alpha, and the speed of projection is 50. If I have to find what is the range of this projectile on the inclined plane, what is the method we use? We simply substitute y naught is equal to x naught cos alpha in projectile equation. We substitute y naught is equal to x naught tan alpha in the projectile equation, and once we substitute in the projectile equation, projectile trajectory equation, only unknown in the equation will be x naught, which can easily be calculated. Once we have the value of x naught, y naught as well as OP can be calculated. OP value will be equal to x naught by cos alpha. So we have x naught, and we can, the range will be equal to x naught by cos 30, which is 500 by 3 meter. So what is special about inclined plane projectile is same projectile, only the time of flight and the range will be shorter, because its motion will come to end as soon as it hits the inclined plane. What is the method we use to find out range, or what is the method we use to find out range? First we find out x coordinate of point P where it hits the inclined plane. We find the x coordinate. How do we find the x coordinate? Using the trajectory equation. We substitute y naught is equal to x naught tan alpha in trajectory equation, and only unknown in the equation will be x naught, which can be calculated. And once we have the value of x naught, the range can be calculated, which will be equal to x naught by cos alpha. So more or less same as normal projectile motion, only difference being its motion comes to an end not when it reaches horizontal level. Its motion comes to an end moment it hits the inclined plane. Hence the time of flight and range changes. Until this point, everything is same. How do we find time of flight here in this case of inclined plane? So what is time of flight? Time it takes to reach point P. Now we are interested in time, so we have to use equation which has time term. So what we'll do, so again we'll express this x naught and y naught in terms of time parameters. So if it takes time t to reach from O to P, x naught is the displacement along x axis in time t, and y naught is displacement along y axis in time t. So x naught will be equal to u cos theta t, and y naught will be equal to u sin theta t minus 1 by 2 gt square, t being the time of flight here. But again, as before, there is a special relationship between x and y coordinate, because this point lies on the inclined plane. Tan alpha is equal to y naught by x naught. We substitute this value of y naught and x naught in this equation, and we take x naught here. It becomes equal to tan alpha into value of x naught, u cos theta t, equal to y naught. We substitute the value of y naught, which is equal to u sin theta t minus 1 by 2 gt square. 1 t gets cancelled, and then we can easily calculate value of t. T will come equal to 2u by g sin theta minus cos theta tan alpha. Simple simplification. One special thing what we notice about time of flight here is the first term here. What is the first term? 2u sin theta by g, which is same as time of flight for a projectile on horizontal surface. So this time of flight on inclined plane is less than this. That's why negative sign, which makes sense, because as the angle alpha increases, the time of flight will keep getting shorter and shorter. If alpha is equal to 0, if you substitute alpha is equal to 0, this equation reduces to the same time of flight what we have in case of horizontal plane projectile. So this time of flight is shorter than time of flight in case of projectile on a horizontal plane. So again, for the same number as before, if angle the inclined plane makes from the horizontal is 30 degree, projection 60 degree, u at 50, simply we substitute the values, we find the time of flight is equal to 100 by root 3 seconds. So we'll calculate one more thing, the time when projectile is parallel to the inclined plane. What does this mean? When is the projectile parallel to inclined plane? In other words, same thing you can say when the velocity vector of the projectile is parallel to inclined plane, or direction of motion of the projectile is parallel to inclined plane. For that to be parallel, the angle made by the velocity vector from the horizontal has to be same as angle made by the inclined plane with the horizontal, which is alpha. So velocity vector of the projectile should make an angle alpha from the horizontal. In terms of equation, tangent alpha has to be equal to y component of velocity divided by x component of velocity at time t. We substitute the value of y component and x component. Y component is u sin theta minus dt. X component is equal to u cos theta. From this, if we rearrange the terms, value of t can be calculated, which comes equal to u by g sin theta minus cos theta tan alpha. And if you recall from the previous slide, this is exactly half of the time of flight. So whatever time it takes to reach from here to point P, at half the time the velocity will be parallel to the inclined plane. And not surprisingly, this property is very similar to what we have in case of projectile motion on a horizontal plane. The time when the velocity becomes parallel to the horizontal surface is half the time of flight in case of projectile on a horizontal plane as well. Again, if you put the values, we can find the previous case the time of flight was 10 by root 3. Here the time when velocity vector becomes parallel to the inclined plane is half of that. So previous cases we have seen the inclined plane was sloping upwards. What happens if the inclined plane is sloping downwards, as shown in the figure here? So again, O is my point of projection, but unlike previous cases, the surface is sloping downwards. Again, we take the point of projection as origin, and horizontal direction x is positive, vertically upward direction y is positive. If you follow the same sign convention, let's say if the projectile is fired from here, it will continue its motion even after crossing the horizontal level further and hits point P on the inclined plane, having coordinate x0 and y0. Given this sign convention, both alpha and y0 will be negative. Both alpha and y0 will be negative. So what will the relationship between alpha x0 and y0? Tan minus alpha, as the alpha is negative, will be equal to minus tan alpha is equal to minus y0 by x0. So when we substitute the value of y0, y0 will be equal to minus x0 tan alpha. In the trajectory equation, in place of y coordinate, we will substitute minus x0 tan alpha. Rest all everything remains the same. So once we substitute in this equation, one x0 gets cancelled out, value of x0 can be calculated, or x coordinate where the projectile hits the inclined plane can be calculated. And after calculating so this equation using this calculator, only thing what we notice, compared to the previous equation tan alpha was positive. Since the alpha is negative, you put the minus tan alpha here. Using this equation, x0 can be calculated. One x0 is calculated, even the range also can be calculated. So when a projectile is projected down the slope, only change what we make is, in place of y0 is equal to x0 tan alpha, it will become minus x0 tan alpha. The rest all remains the same. Now let's come to another case. What would be the time of flight and range for a projectile which is fired from a certain height above the ground? So as shown in the figure, the point of projection is h meter above the ground surface, and it's a speed of projection is u, angle projection is theta measured from horizontal. So what would be the time of flight in this case? Time of the flight would be, it will continue its motion. Time of flight will not end here, the flight will not end at this point. Since it is fired at a certain height, it will continue, and when it hits this point on the ground, the time taken to reach from this point to this point is my time of flight. So how do I define this time of flight? Time when it hits the ground. And what is the ground here? If I choose this as my x-axis and y-axis, how do I define this ground? Ground is y is equal to minus h. So it will hit the ground when its y coordinate becomes minus h. And in other words, if I look at its displacement along y-axis, its displacement from the point of projection along y-axis has to be minus h. So in this particular case, unlike the horizontal projectile, the time of flight will correspond to displacement of minus h along y-axis. The time of flight will correspond to displacement of minus h along y-axis. Why minus h? Because it is below initial point of projection. So since we know displacement and we want to find out time of flight, we use the formula s is equal to ut plus 1 by 2 at square applied along y-axis. So in place of s, we substitute minus h, ut, initial velocity in y direction is u sin theta into t dash, which is time of flight, minus 1 by 2 gt dash square. So this equation, it can be solved for t dash. This is quadratic equation. We will find one value positive, one value negative. The positive value will be the valid value, which will be the time of flight. For example, if we take u is equal to 50, theta is equal to 37 degree, h is equal to 35 meter, and g is equal to 10, of course downwards. We substitute the values here. The equation will reduce to minus 35 is equal to 30 t dash minus 5 t dash square. We solve this equation, we get the t dash is equal to 7 seconds, which means it will hit the ground at 7 seconds after it is fired from this point. Had the ground been horizontal, we can easily calculate for if the ground was horizontal or had the same projectile been fired from a point on the ground with the same angle, the time of flight would have been 6 seconds. It means it has taken 1 additional second to reach from this point to this point. So time of flight is larger compared to what it would have been had it been fired from the ground. If we take higher and higher above the ground, the time of flight will keep on increasing. Once we have calculated the time of flight, calculation range is very simple because we know what the range is. Range is displacement along x-axis during time of flight. So if we have found out the value of t dash, range will be equal to u cos theta into t dash. If we take this above example, we substitute the values u into cos theta into t dash, we find the range will be equal to 350 meter. So it will land at a point which is 350 meter measured along the horizontal level. Thank you.